Man, it feels like every single time we open our news feeds lately, OpenAI launches a new model, right? A new version drops, it writes better code, it casually passes the bar exam, it generates these breathtaking videos, and suddenly the entire cultural conversation just shifts overnight. But behind the magic trick of typing a prompt and getting a stunning output, there's a fascinating, highly structured layer of technology. Welcome to this explainer. Today, we're peeling back the layers of these AI models to understand exactly how they work, how they're built, and why they are evolving so unbelievably fast.
Okay, let's dive right into this. 175 billion. Now, that's not just a big number. That is the exact number of parameters packed inside OpenAI's GPT-3 model. Just to put that into perspective for you, that's roughly double the number of neurons in the human brain. This massive jump in scale back in 2020 was an absolutely pivotal moment. By giving the AI way more parameters, which are essentially the artificial synapses connecting its neural network, the model started exhibiting capabilities that genuinely shocked even its own creators.
And honestly, the results of that scale? Absolutely staggering. Stanford research recently dug into how well these large language models can perform what are known as theory of mind tasks. Basically, this means understanding hidden context, like knowing that if someone moves an object without another person seeing it, that second person is still going to look in the original spot. Well, in 2020, the models got it right about 40% of the time, roughly the cognitive level of a 3-year-old. Just 3 years later, newer versions jumped to a 90% success rate, putting them right on par with a 7-year-old. To really understand how this massive leap happened, we're going to need a roadmap.
So here is our path forward today. 1. The OpenAI Revolution. 2. Unpacking generative AI. 3. Inside neural networks. 4. The transformer breakthrough. 5. How models actually learn. And 6. The future of intelligence.
All right, Section 1. The OpenAI Revolution. Scaling the heights.
Look, the constant stream of news about AI breakthroughs can feel totally chaotic, right? But behind the scenes, every time OpenAI launches a new model, it's actually following a remarkably deliberate timeline of scaling up. In 2018, GPT-1 launched with 117 million parameters. Just a year later, GPT-2 expanded to 1.5 billion. Then in 2020, GPT-3 exploded to 175 billion parameters. By late 2022, they introduced ChatGPT to the public, fine-tuning that architecture specifically for conversation. And in 2023, GPT-4 launched, scaling those heights even further. The takeaway here is that this isn't just linear growth. Model scale is compounding exponentially.
Moving on to Section 2, Unpacking Generative AI, Busting the Jargon.
Now, what's really interesting about this is that we constantly hear terms thrown around like AI, LLMs, and generative AI, kind of like they're all the exact same thing. Well, let's clear that up. Generative AI is a specific class of machine learning. The absolute key word here is produces. Instead of traditional AI that just classifies data, like recognizing a face on your phone or detecting credit card fraud, generative AI actually creates original material. It learns deep, complex patterns from vast data sets and then uses those patterns to draft emails, generate breathtaking images, or even write complex software code from scratch. It is literally the leap from analysis to creation.
Building on that, large language models, or LLMs, fit right under that generative AI umbrella. You can think of LLMs as giant statistical prediction machines. And this is exactly what you're interacting with when you use ChatGPT. They are trained on immense text datasets, and their core job is incredibly simple, yet mind-bogglingly complex. They just predict the next word in a sequence. Through billions of prediction exercises, they absorb human grammar, facts, context, and writing patterns to generate highly coherent text.
Let's really cement this concept. Think of predictive AI as a weatherman. It forecasts outcomes based on past data, telling you what your sales might look like next quarter, or estimating the risk for an insurance policy. Generative AI, on the other hand, is more like an artist. It creates entirely new, original content based on the patterns it's learned. It's what you use when you want a brand new marketing slogan or a synthesized image for your campaign. They are very, very different tools in the AI toolkit.
Okay, Section 3, Inside Neural Networks, the brain of the operation.
Let's peel back the next layer of the onion here. If generative AI is the broad category, the neural network is the actual, literal brain powering all of this generation. And when it comes to generating visual data in particular, there are a few fascinating ways to build these brains. One method involves GANs, or generative adversarial networks. Think of this as a master art forger and an art detective actively competing against each other. One generates an image, the other tries to detect if it's fake. As they battle it out, the generator gets incredibly good, producing very sharp, realistic outputs, though they can be highly unstable to train. Another method relies on VAEs, or variational autoencoders. These compress data into simpler forms and then recreate it using probabilistic variations. They're much more stable to train, but they do tend to produce slightly blurrier outputs. So, different structures, totally different strengths.
Which brings us to Section 4, the transformer breakthrough, the engine.
So the crucial point is that while GANs and VAEs are amazing for visual tasks, the real revolution in text happened back in 2017. A team of Google researchers published a paper that fundamentally changed natural language processing forever. It was famously titled, "Attention is All You Need." See, before this paper, AI models read text sequentially, word by word. They frequently completely forgot the beginning of a paragraph by the time they finally reached the end. This paper changed absolutely everything.
That 2017 paper introduced a mind-blowing concept called self-attention. Basically, self-attention lets the model break data down into fragments called tokens, but instead of reading them purely in order, like a human reading a book, it calculates the relevance between every single token in a sequence simultaneously. It looks at the whole picture all at once. If it sees the word bank, it instantly weighs the surrounding context to know if you mean a riverbank or a financial institution. This breakthrough understanding of long-range context is the very engine that unlocked the massive models we rely on today.
All right, Section 5. How models actually learn, the process.
We've talked about the architecture, but how do you actually take a blank neural network and train it to be an expert on, well, everything? It follows a really rigorous 5-step process. It starts with input, funneling massive amounts of text, audio, or video data and sorting it all out. Then comes processing, where the AI's algorithms hunt for hidden patterns. In step 3, outcomes, the AI uses those patterns to make a prediction, deciding if the new data matches the established rules. Step 4 is absolutely crucial, adjustments. When the model makes a mistake, the algorithm tweaks its artificial synapses, and this process repeats literally millions of times. Finally, assessments, synthesizing all these learned insights so the model can confidently and accurately predict the future.
Let's move on and see how this builds, because once training is done, we enter what's called the inference process. This is exactly what happens when you type a prompt into ChatGPT. The model doesn't actually know the final answer in advance. First, it tokenizes your prompt. Then, it converts those tokens into numerical embeddings, basically translating our human words into math that the machine can compute. From there, it calculates the statistical probabilities for all potential next tokens based on everything it learned in training. Finally, it outputs the most likely token one by one. Every single time you hit enter, the model is making its absolute best guess at staggering speeds at every single step.
Finally, Section 6, the future of intelligence, the horizon.
We've peeled back the layers from massive parameter scale all the way down to how a model mathematically guesses the next word. But where is this all rapidly leading us? Remember that Stanford research we talked about earlier? In 2020, GPT-3 scored 40% on theory of mind tasks. Just a couple of years later, that skyrocketed to 90%, and with the launch of GPT-4, the model hit 95%. Every time OpenAI launches a new model, the speed of improvement in understanding human-like hidden beliefs is just breathtaking. It's actively learning to navigate the unsaid, the inferred, the deeply human aspects of communication. And that brings us to the 4 theoretical types of AI. The first is reactive machines. These are task-specific, no memory, kind of like a basic chess computer. Now we are currently firmly in the second stage, limited memory. These models act like our brain's neurons, getting smarter as they collect and train on massive amounts of data. But we are rapidly approaching the third stage, theory of mind. As we just saw, we're starting to see real, tangible glimpses of this. AI that can understand that other entities actually have thoughts and hidden emotions. The final stage, of course, is self-awareness, true realization of existence. We aren't there yet, but I'll tell you what, the milestones are blurring together fast.
Which leaves us with a pretty provocative question. With GPT-4 answering theory of mind tasks correctly 95% of the time, which is literally on par with the cognitive logic of a human 7-year-old, what happens when the next model is launched? As parameter counts rise and transformer architectures grow even more efficient, the leap from a 7-year-old's logic to full-blown adult reasoning might be just one major launch away. The OpenAI revolution is moving insanely fast, and now you understand the engine driving it forward. Thank you for joining me on this explainer, and definitely keep your eyes on the horizon.